All right, you guys. So we're going to go over the test review today for graphing logs and exponentials. All right, so first thing we want to list the transformation. So remember, whenever you have something added or subtracted out here, that's going to either move it up or down. So this is a vertical translation. I'm not going to write out the full word because I'm lazy. Up 3. Okay, so we went up 3. Okay, anything inside with x, well, inside in this case, I mean really up with x, is going to be either left or right. And remember, we always lie to our x's. So -4 really means to the right 4. So horizontal this time, right? Horizontal translation, right 4. Okay? And then last, so some people get confused because they think that 1/2 is a shrink, but y'all, the base this time is just a 1/2. That's not a transformation. A transformation is when something's in the front. And since that 2 is in the front, being multiplied in the front, that's a vertical stretch. Oh, vertical stretch by 2. Okay, so don't get confused. That 1/2 is the base. So when I go to graph it, remember we use our key points 0, 1, 1 in the base. And the base this time is 1/2. Okay, so whatever is underneath the exponent is the base. Okay, and then remember we want to move our values based on our transformation. So think about it. Our x values, we need to move them to the right. So to move our x values to the right, we're going to add 4 to them. Okay, and then for our y values, we need to stretch them. So we're going to multiply them by 2, and then we got to move them up. So we're going to add 3. Okay, and so really it's just what happens is that everything up here with the x goes with the x. Everything else on the outside goes with the y. So this goes with the x. These go with the y. Okay. Anyway, so now we just add, right? So 0 plus 4 is 4. 1 plus 4 is 5. Here we multiply by 2. So 2 times 1 is 2. Plus 3 is 5. And then 2 times 1/2 is 1. Plus 3 is 4. Okay. And then the only other thing that you really have to graph is the asymptote. And for exponential, think about it as exponential has a horizontal asymptote, and horizontal is y equals, right? So I'm going to go down here where it says asymptote, right? Y equals. And so the y values, remember, it normally is at 0, but our y values have moved up to 3. So it's going to be at 3. Okay, so I'm going to plot my horizontal asymptote at 3. Okay, and then I'm going to plot these points. So 4, 5, 4, oh, that's 4, 4. 4, 5, and then 5, 4. Okay, and you can kind of see, and this one's going to be going down because it is it's a fraction here, right? So it's kind of like decaying. So it's going to go like this, right? So I kind of drew that from the left to the right. But remember, it is going down, and then it skirts along the asymptote, right? All right, so for domain, remember for these is always all real numbers. So negative infinity to positive infinity, and that's for all exponentials. And it's because if you look at this, right, this side is going to the left, this side is going to the right. So it's going forever, so that means the domain is going to be all real numbers. But the range this time, well, the range doesn't go down here, right? We don't go in these negatives at all. We start at the asymptote, and then it's everything up from that, right? So it's actually going to be 3 to infinity. And it's always really just like the asymptote to either, if it's going up, positive infinity; if it's going down, it's going to be negative infinity. All right, interval of increase or decrease. So first of all, this is decreasing, right? You read the graph from left to right, and the interval always kind of mirrors the domain. And it's just because the interval of increase and decrease, we write it as our x values, and our x values are the domain values. And because it's always decreasing, we don't really have to split that interval in half or anything. So we just write all that over all the x values, it is decreasing. All right, so x-intercept, this one actually does not cross the x, so there's a none, right? It does not cross that x-axis. But it will eventually cross the y-axis, and we don't want to just guess because we have no idea really. So the way we have to solve for the the y-intercept is we plug in a 0, okay? So let's plug in a 0 for my x, right? Because that's going to solve for y, right? So I'd have y equals 2 times 1/2 to the 0, right? If I put a 0 here, 0 minus 4 is just -4, and then plus 3. And you guys can just type that into the calculator to find what the y is. Okay, so actually I never opened my calculator. Let me do that real quick. But it's going to take me a minute, or the calculator a minute. So anyway, but you type it in just how it looks. So it's going to be 2 parentheses 1/2 raised to the -4, and then, let me put that in parentheses, and then plus 3. Okay, so you should end up getting 35, and I'll show you once that kind of pops up, but you should have gotten 0, 35. Here, let me see if that's popped up yet. Okay, yeah, let me show you. Okay, so if I clear that out, 2 parentheses 1/2 raised to the -4, then off to the side we have plus 3, right? And you should get 35. All right, so that's how we solve for the y-intercept. All right, and then end behavior, remember, so for these, our x's go from -infinity to +infinity, right? So we're just trying to figure out, it's just a fancy way of saying on the left side and on the right side, what's happening. So on the left side of our graph over here, well, the left arrow is going up, so we're going to say it's going to infinity. But the right side doesn't really go up or down. This is kind of flattening out, and it flattens out at the asymptote. So we're going to say it flattens out at 3. Okay? So those are our key features. All right, so let's keep going. All right, so now we're going to graph a log. So same transformations. The transformations never change. So anything out here is is going to be up or down. This time it's minus, so it's going to be down. So it's going to be a vertical translation down 1. Okay. Inside, remember, inside with the x is going to be left or right, and you would think a plus would go right, but really we lied our x's, so it's really going to be left. So that's a horizontal translation left 3. All right, and then the last thing is the negative in the front, and remember, a negative in the front means a reflection over the x-axis. Okay? All right, so same thing. We're going to start with our basic chart. So remember, it's opposite of what we did earlier. So instead of 0, 1, 1 in the base, now it's 1, 0. So remember it as like, it kind of looks like LO, like kind of like the start of log. 1, 0, base 1. And the base this time is 3, right? So 1, 0, base 1. That's the starting chart for log. And then we make our new chart, right? So to make our x values move to the left, we're going to subtract 3. Remember, everything with the x goes with the x, everything else goes with the y. So to reflect our y values, we multiply them by multiply them by a negative, and then move them down, we subtract 1. Okay, and then we just do it. So our x values subtract 3, so 1 minus 3 is -2, 3 minus 3 is 0. Okay, well, 0 minus 1 is -1. And then -1 minus 1 is -2. So those are our new points that we're going to graph. And then remember, for log, if we start with log with an L, right, it has a vertical asymptote. And vertical lines are going to be x equals, and they're going to move to the left or to the right. And in this case, we've moved to the left. So we're going to move to the left 3. Right, that's where we moved, left 3. All right, and then we're going to plot these points. So -2, -1, and then 0, -2. All right, and this one's been reflected. So instead of going up, it's going down. So remember, we go along the asymptote, and then it kind of like quickly goes off to the right. All right. All right. So domain this time. So for domain, our domain does not go over here to the negative x values, right? Because that asymptote is stopping it. So that asymptote stops it at -3. So this time the domain is the one that's not all real numbers. And the range this time is all real numbers because this is going down to these negative numbers and up to the positive numbers, right? So the range this time is -infinity to +infinity. So it switches. Remember, the domain and range flip for logs and exponentials. All right, so we already determined the asymptote was at -3, right? This is decreasing, and remember, we use our x values for the interval of increase and decrease. And since this is always decreasing, we say over all the x values, which is just the same thing as the domain here. So -3 to infinity. All the x values, it's always decreasing. Our x-intercept, so we can't really tell. We know it's going to be like somewhere around here, like -2 point something, but we can't really tell. So whenever you can't exactly tell, you have to solve for it. You cannot guess. So we're going to set equal to 0, our equation equal to 0, and we're going to solve. We have to solve for x. Remember, every time we solve for x, like we did in the last unit, we were solving for the x-intercept. That's what we're always solving for when we solve for our x values. So anyway, x plus 3, what is it, -1? Yeah. All right, so we got to solve this. We set it equal to 0, and we solve. So let's go through and solve this. So first, remember, we always move the outside parts first. We do order of operations backwards. Okay, so we're going to have 1 equals -log base 3, x plus 3. Okay, and then that negative, you can't do a base of 3 yet because that negative, if I had a 3 here, that negative, this is in the way, right? That's in the way. So we can't do that. Instead, we have to divide by a -1 first. Okay, so that cancels. We get -1 equals log base 3, x plus 3. Okay, and then we put a 3 down. So those cancel. We have 3 to the -1 equals x plus 3. And then remember, we just subtract 3 over. So we just subtract 3. All right, and so we're going to have 3 to the -1 minus 3. So we can type that into the calculator, right? So let's type that in, 3 to the -1, and then minus 3, right? And we get -2.6 repeating, so -2.67. So our x-intercept is -2.67, comma 0. Okay? And then our y-intercept is actually like a perfect point this time, so we don't have to calculate it like we did in the first one. Our y-intercept is 0, -2. All right, and then for end behavior, so for end behavior, remember, we would normally write -infinity, +infinity, but our x values don't go into -infinity and +infinity. So instead, it goes from -3 to infinity. So we just have to keep that in mind, that it doesn't actually go to -infinity. So we have to write -3 this time. But it's still talking about the left side and the right side. All right, so the left side of our graph is going up, so we're going to write infinity. And then the right side of our graph is going down, so we're going to write -infinity. Okay, so super, super easy. All right, so that is the whole first page. All right, let's keep going along. Okay, so now we're going to graph an ln function. And ln, y'all, is the same thing as log. You're going to do it the same way. You use the same base points. The only thing you use is that ln has a base of e, right? So whenever you do 1, 0, base 1, you're going to use that base of e, which is 2.7, right? So let me write that down. So this has a base of e, which is 2.7 is approximately the value. So we're about to actually get cut off on this video, so I'll go through and do this problem on the next video.